This is part 5 of our lesson on vector addition and subtraction, and we are going to look at how to add and subtract vectors using components. So using components is the physics way of doing it. So this is something, if you've taken physics, this is how you probably added and subtracted vectors. So looking at components, we're basically trying to break everything down into right-angle triangles. So this is the same question that we did in the previous video. It is the one here that says, determine a plus b if the magnitude of a is 5.2 centimeters, the magnitude of b is 7.2 centimeters, and the angle between the two vectors is 40 degrees. Okay, I am going to start by just drawing a rough picture of what this looks like. I am not going to measure with my ruler. I am not going to use a protractor. I just need a picture to sort of start with. So I have vector A. I've got vector B that's at 40 degrees, and it's longer than vector A. That's all I really care about, is that it's longer and that it's roughly around the 40-degree mark. Here's A, here's B. I still add vectors by lining them up from head to tail. So I need to take vector B and slide it over so that it lines up to make one continuous path with vector A. And then my resultant vector, or the sum of the two vectors, is drawn from the tail of the first, so where we started, to the head of the last, or where we ended. Okay, so this method is a little different because what we're going to do is try to break everything down into right angles. Now, because it didn't tell me what direction, like north, south, east, west, they were pointing, I am able to just make vector A horizontal and then add vector B on from there. So what I want to do is take the resultant vector and see if I can create a right angle triangle out of that. So I am going to try to take this and then extend A to create a right angle triangle between the three parts. So I'm going to come down like this and connect over like this so that that is one straight line and makes a right angle. I didn't do a very neat job of that. I didn't use my ruler, right? So I took what I had and I just extended A. I dropped down from the end of B to make a right angle there. So I am going to label what was in the question. So this part here, A is 5.2, that's its magnitude. And then B is 7.2, that's its magnitude. And I know that this angle here is 40 degrees. Now, if I draw this and I continue this side on so that it is one continuous side, if this angle here is 40 degrees, this angle here is also 40 degrees. Just looking for my other, this one. So what happens is I want to find this side here, and I'm going to try to do it by using this big right angle triangle. The problem is I don't know how long this is, and I don't know how high it is. But I do have the tools to be able to figure that out. Because I know that this angle is 40 degrees. I know this side is 72. So I should be able to calculate the height of this triangle and the base of this triangle. And then once I know that, I can use that information to help me figure out the big triangle and then find that side there. So let's start with the little triangle. We're going to try to find x. We're going to try to find y. It is a right angle triangle, so I can use SOHCAHTOA or the sine, cosine, tan ratios. If I'm looking at this triangle, the hypotenuse is across from the right angle. So this would be my hypotenuse. This one is across from the angle, so it is the opposite. And then this one down here is the adjacent. Sometimes I do find that the diagrams get very crowded and there's a lot of things labeled and I get a little lost in how I've labeled some of the things, as you noticed in the previous question where I kept thinking vector A was side A. So sometimes what I might do is just draw a little rough picture underneath to just help me isolate the triangle from all the other stuff that's currently going on the page, right? So there's my little right angle triangle. It's got an angle of 40. It's got a side of 7.2. We want to find x. We want to find y. We said this was the opposite. This is the adjacent. This is the hypotenuse. Okay, so we're going to do it one at a time. I think I would do x first. So I am going to start by trying to solve for x. If I want to solve for x, that's the opposite. The side I know is the hypotenuse, which means I would use the ratio for sine, which is opposite over hypotenuse. Those are in your yellow package if you don't remember. So sine of x is, well, I shouldn't have used x. I'm going to use theta. It's a Greek letter we use for angles. Is opposite over hypotenuse. So sine of 40, that's the angle, is opposite x over hypotenuse 7.2. And then to solve, I would just multiply both sides by 7.2. So I would do 7.2 times sine of 40 to calculate the length of x. 7.2 times sine of 40, and I get approximately 4.628, or that would round up to 4.63. And that should be centimeters. So that means this side here is roughly 4.63. So this side up here is roughly 4.63. Oh, you can't see that. All right, then I'm going to find y. Options. I could use adjacent and hypotenuse, that's cosine. I could use adjacent and opposite, that's tan. I could use Pythagorean theorem. All of those methods would work. I like the idea of using the side that I was given in the question so that it is a little bit more accurate when I'm calculating. So I think that what I'm going to end up doing is using cosine, but you could use, like I said, tan or Pythagorean theorem. So I'm going to say cosine of theta is adjacent over hypotenuse. So cosine of 40 is adjacent y over hypotenuse 7.2. And then same thing as last time, I'm going to multiply that 7.2 to the other side. And then calculate. All right, and I ended up with 5.515, so 5.52. Which means this down here is 5.52, and this part here is 5.52. Okay. So we are trying to solve for the big side, a plus b. So I'm going to look now at this large triangle that has a height of 4.63. And then for the base, I'm going to add 5.2 and 5.52 together to find the total length of this part. So like I did here, I think I'm going to draw the big triangle just because it's easier for me to see what I'm doing if I do that. So over here, I'm just going to draw the big triangle. I know this is 4.63. Now the bottom is this plus 5.2, which is 10.72. And we are hoping to find that side there. Now, I've already used x and y, so maybe I should call that z. And we are also going to need to find this angle in here. So I'm going to need to find that. So let's call that w. So to find z, I could just simply use Pythagorean theorem. So I could do a squared plus b squared equals c squared. Now the hypotenuse is always the c, so it is across from the right angle, which would be here. And then a and b, it really doesn't matter which one is which. It all works out in the end. So this is going to be 10.72 squared plus 4.63 squared equals z squared. I think I'm just going to add all of that together in one here. So I'm going to do 10.72 squared plus 4.63 squared, which is 136.3553. And then to get rid of the square, I'm going to square root. As we all know, when we square root something as part of our solving, that does mean that I'm supposed to do plus and minus, but minus just doesn't make sense here. So we tend to ignore it. So this is approximately 10.677 or 10.68. I say because it's not quite the same answer I got when we did it in the previous part. We'll talk about that in a second. In order to find the angle, I need to use some trigonometry. So this side here is my hypotenuse. This is across, so it's the opposite, and this is the adjacent. I was given opposite and adjacent, so I could use tan. I could use the hypotenuse and do either sine or cosine since I've calculated it, but I think I'd like to use these two values. Every time I do a calculation and round it, it gets a little less accurate, so sometimes it's a good idea to try to not round as much as you can. All right, so from here I'm going to do tan. So tan of W equals opposite over adjacent. So tan of W is 4.63 divided by 10.72. And then I'm going to do the inverse tan of that. All right, so 4.63 divided by 10.72, and I do inverse, oops, I have to hit equals first, and then inverse tan. I get 23.36 degrees. All right, so according to these calculations, A plus B is 10.68 centimeters, and it is 23.36 degrees with A. All right, we have now done the same question 3 times, 3 completely different ways, and we got roughly the same answer every time. So when I drew it, we got 11.7 centimeters, and it was 24 degrees with A. When I did cosine law, I got 11.67 centimeters and 23.40 with A. And then this time, I got 10.68, which was a little bit different, and 23.36 degrees. Now, the reason why these answers don't completely match this one is because I rounded in the middle, right? I calculated these sides and I rounded, and then I used rounded answers to answer the next part. If I had kept these as exact, like if I had left it as 7.2 sine 40 or 7.2 cos 40, I should have ended up with the exact same answer I did in the previous part. So I showed you all 3 methods. It is up to you which one you want to use. If you want to draw, draw. If you want to use cosine law, use cosine law. If you want to use components, use components. I am okay with you using any of those methods, although you are going to have to check with your new teacher what method they would like you to use, but I am usually okay with any of those 3 methods. All right, that is it for addition. However, we need to talk about subtraction, so I will see you in the next video for subtraction.